stop talking at some point, because I just got so busy talking last period. I was like, never mind about that homework, guys. It's not going to happen. You would be nice if... You would be nice, English. It would be nice if you had a graphing calculator out. There's an extra one right here because my children can't put things up, as you know. There you go, too. Perfect. There are some up here in my holder that are still available. It looks like I got about 10 or so. It would be nice if you had a graphing calculator today. In fact, we'll just start with that. That way we can all be on the same page as to clearing stuff out. Because, bless your heart, since these are communal graphing calculators, English today. Since these are communal graphing calculators, it's best that we know how to clear them out to begin with. That way other people aren't messing you up. Okay, so the easiest thing to do, anyone else want a graphing calculator? Well, let's go. Okay, the easiest thing to do when you get on your calculator, if you're wanting to just basically clear out everything anyone's ever done, because you're like, nope, don't care. You could go, and I don't care if you do this. I do it all the time. You could press second, and then MEM. It's the one up from the bottom. It's the plus sign, but it's in blue. So you could press second, and then MEM. And then you could say that you want to reset, which is number 7. And then it says, do you really want to do all RAM? And you say yes. And then it says, like, but are you sure? And you're like, yes, I want to reset. And if you do that, it'll say RAM cleared, and the whole bad boy's cleaned out. And that part seems nice. Now, if you're consistently, like I use 24 every day, if you're consistently using the same calculator every day and you don't want to do that, you can just delete what they're doing. But I teach a lot of, Altitude Trick, but we use the calculator a lot in AP Stats. So there's potential that they're killing and messing up your graphs. So if you don't want to clear it out, but you do want to like get rid of the stat people stuff because it's making your graphs look crazy, if you press second and then stat plot, you just want to make sure that you see the word off. See, like off. That's what you want to make sure. So if you're trying to be nice and you don't want to clear it out, even though I'm telling you that's fine, they should have gotten their own calculator. I told them to forever ago. If you'll press second and stat plot, it's in blue, and just make sure stuff is off. That way their stuff's not slowing you down. And if you didn't get all that and something messes up, I'll show you what to do. And then a good way to get out of whatever it is you're doing is second quit. Second quit clears and you're free. You're free at last. Free at last. Okay, put that bad boy to the side. I promise we're coming back to him shortly. I need help with my math workshops. I'm hoping someone out here knows perfect squares. Yes, ma'am, number 7.
16
Okay, so she is correct. It was, what's 16 squared? A point for table 1 and a point for table 3. So 256, the square root of 256 is 16, so it is 16 root 3. That is correct. That is correct. Now for the next one, number 8. Yes, ma'am.
24.
It is 24. Did you remember your perfect squares? We memorize them for a reason, and is a perfect square, so it's 24. Number 9. Yes, ma'am.
9 root 6.
It is 9 root 6. Elizabeth's not here. Paige, you can have a point, and Angel, you can have another point. It is 81 times 6, which is square root of 81 is 9, so 9 root 6. Anybody in the back want to do number 10? Yes, Jax. So I thought 100 times 8, and that's not the goal. That's not a good one. Don't pick it. Ma'am, we'll let you go. We'll just bounce back and forth between the two of you. Yes, ma'am.
20 square root of 2.
That is correct. Okay, so the answer is 20 square root of 2 because you want to do 400 times 2, and the square root of 400 is 20. Number 11, Angel.
7 root 2.
It is 7 root 2. You want to do 49 times 2. The square root of 49 is 7, so 7 root 2. Another point for your group. You're freaking on it today. Yes, dear.
4 root 2.
It is 4 root 2. That one was, I think the easiest one of the day was last. 16 times 2 is 32. Square root of 16 is 4, so 4 root 2. Do you see how they were prepared and they were freaking on it today? You could all be like that and get 13 and 14 done tomorrow. Especially 13. I assume you're going to try to cry on 14. My suggestion for 14 is to put them all in y equals mx plus b. So the third equation is not, it looks like it's in standard form. Rearrange it to y equals mx plus b. Okay, let's go to our notes. We are not going out of order today. Yesterday, if you weren't here because you went on a field trip, we did a short lesson. It was very fast on graphing linear inequalities. It's on YouTube. And we did a checkpoint with it. And that went really fast. We're on the third page today. It's page 27 at the bottom. Okay, so we did that lesson. It was really fast, and I was excited because I was like, yes, this is on the next test. They can do this. This is easy. I'm glad this is a chunk of the next test. But you know, another chunk of the next test coming up is that piecewise function quiz that I still haven't quite gotten all graded. I should have those back to you by tomorrow because my goal is to test on Tuesday, so we need to review on Monday. So I really need, Lord Jesus, at least I know your name. I really need Ellie to know what she did wrong with her piecewise function quiz as soon as possible so she can readdress it this weekend, get it together, and save the day on Tuesday. If for some reason I can't get those quizzes done tonight, then I guess that means the test is moved to Wednesday. We're going to pray I can pull off the miracle because I don't want to push back the test. Okay, and then I'm going to be rebellious today, and we're going to skip around a bit. You're supposed to have homework, page 32 through 34. It's in the notes. But, again, I rambled so long first period, I canceled their homework. So maybe that'll happen this period, or maybe I can finally get my words out fast enough. We shall see. Okay, we're going to cross off that first sentence. We just ain't got time for that. The parent function. So we've done piecewise, we've done graphing linear inequalities, and today we're going to talk about parent functions. And we're only going to talk about 3 parent functions. The parent function is the simplest of the graphs in a family. It's the graph that's transformed to create other members in a family of graphs. So what on earth does that mean? We're about to talk about it. A few weeks ago in our math workshop, the very top couple problems were on parent functions. We had to say, oh, that's the quadratic parent. Oh, that's the linear parent. Today we're only going to have 3 parents. If you're in pre-cal, you have to know like 10 different parents. There's a lot of different parents out there. There's a linear parent, a quadratic parent, an absolute value parent, a square root parent. There's so many parent functions. Cube root parent. There's so many parent functions. But for today and for this chapter, we're only going to talk about 3. And seriously, you already know 2, so there's only 1 that's going to be new. So the first one we're going to talk about is a constant function. Now, if we're going to name the parent, like who is the parent, it's weird to do it with a constant, but you know, I'm a creature of habit, so since I'm going to do it with the other 2, I'll do it with this one. I don't think that's the true parent. I think the true parent is y equals 0, the line through the x-axis. If you move it up or down, then you've changed it, but I think the true parent is y equals 0. No one's going to ask you who's the true parent for a constant, though, just so you know. Okay, so with us, we're only going to have y equals when we're talking about functions. So like y equals 5, y equals 7, y equals -1. We're never going to have x equals 5 because remember, that would look like this. And we're only talking about functions, and that's not a function. So yes, we've had to graph it and do some stuff with it lately. But in this section that's specifically on functions, since that's not a function, it's not going to come up. Okay. The next one I'm a little rebellious about. I want to change the name. I don't like the name identity function. I think it's dumb. What do you think we should call this graph? I agree. And I'm going to give you a point because last period I had to like spell it out for him. I'm going to call it linear. Now, for some reason, in case you can't tell, this is copied from an Algebra 2 textbook. For some reason, Algebra 2 textbooks are calling that the identity function. So if you call linear functions identity function, I'm going to let it go. But I think that's weird. I think linear is a line. You ought to call it linear. When you say the word identity, I think you're talking about maybe it could be the parent graph for quadratics. Or I don't like that word identity. I don't think it fits this function. I think linear fits this function. Okay, so the parent function, the one that gave birth to all the other lines out there, is y equals x. But if we really wanted to spell it out, and it's y equals 1x plus 0. It has an intercept at 0. Its slope is as easy as can be, up 1 over 1. The other day when we were discussing parent functions, we decided that most parent functions cross through what point? Most parent functions cross through the origin. Your group gets another point. Okay, so the last parent function we're going to discuss today is the absolute value function. Notice this parent function is going through the origin, and that's why I rewrote the constant one, because it wasn't going through the origin. I like to think most parents, there are exceptions, there are always those weirdo parents, but most parents go through the origin. Okay, so this last thing is an absolute value function, and it's y equals absolute value x, and we'll come back to how to graph it in just a second. Let's look down at the bottom at 1, 2, and 3. All we have to do is identify, is this linear, is this constant, is this absolute value? So what is number 1?
Absolute value.
I'll give every group a point. Absolute value. What about number 2?
Linear.
Oh, I heard 2 different things.
It's constant.
Okay, it's constant. It's that straight line. It's constant. I'm not going to give out points on that one because it was disappointing. Number 3, and every group can get a point for that one. Linear. Okay, so that's pretty easy, just identifying who is what. But what we're about to talk about is what happened. So we had the absolute value parent function that used to go through the origin, and what happened to move him to make that new function. That's what we're going to discuss today. Okay, but back to that absolute value parent function graph. Let's discuss it a little bit. Absolute value functions are really easy to graph. The parent goes through the origin. If there's no number out front, it's easy to even count. It's like counting the slope. You go over 1 up 1, over 2 up 2, over 3 up 3. I mean, it's just like going over 1. It's just like if you graphed a line with a slope of 1. It's just like that. Up 1 over 1, up 1 over 1, up 1 over 1. Just like that. The only difference is with an absolute value function, since anything you put inside is going to be positive, if you plugged in, let's say, -2 for x, and you're trying to figure out y, well, you're going to get +2. So instead of -2, -2, like it would be with a linear function, if you plugged in -2, you would get out -2. With an absolute value, all the y's are positive, so if you go to -2 on the x, you go to +2 on the y. And if the green doesn't make sense for you, because for some reason for years that didn't click with me, I don't really know why, that all the things had to be positive on the y-axis. Literally, the left side is a reflection of the right side, so I'm also going over 1 up 1, over 2 up 2, over 3 up 3. It helps if you remember the graph of the parent function. It helps in life. But the cool thing that we're going to discuss using today is this handy-dandy device that can do pretty much anything for you anyway. So if you were to forget, you're going to learn how to ask this nicely. Okay, are there any questions about this page? Flip to page 28. It's the next page. We're going to hit the highlights because, my God, there are a lot of words on this page. Whew. Words, words, words. So you and I today, now that we've hit the parents, we're going to talk about how we can transform them, how we can move them. So we're doing transformations. One kind of transformation is a translation, which is when you move something up, down, left, right. So for instance, we drew us a quick little graph. This is what the absolute value parent looked like. I'm going to do him with dotted just to keep track of him. That's what the parent used to look like. What the parent used to look like, but if we translated him down, it would look like this. If we translated down. Okay, so if you translate it left, right, up, down, that seems pretty easy. The next thing we can do with the parent function is that we could reflect it, which is just flipping it. So we're literally going to flip it over that x-axis. So this is what the absolute value parent function used to look like. If we flip him, he literally was a happy V, and now he's just a sad V. When you reflect it, it literally just flips. So that is our reflection. So we can move left, right, up, down. We can reflect him, and the last thing we can do is we can dilate him, which is where you shrink or enlarge. And we might have to come back and hit on this more tomorrow. But basically, if we had our parent function, and he looks like this V of the absolute value, we can either make him really fat, like we made him super fat. He was normal, and then we made him super fat. Or we can make him super skinny. Like here he is, he's super skinny. He's skinny. And my keywords that you might want to write down, and I swear in a little while in your life it'll click. But fractions make you fat. Fractions make you fat. Fractions and fat go together. They both start with an F, and fractions make you fat. Meaning if there's a fraction on the outside of your equation, you would think fractions would make you tiny. In my mind, a fraction makes me smaller. But no, when you multiply by a fraction with this absolute value parent function, and with any function really, it makes you super fat. Super fat. Okay, and then they have this lovely giant chart explaining what you and I just explained in English. They explain it in math. So if you get stuck on something and you're confused, come reference this chart. The only thing I would want to say before we move on has to deal with the translations right here. So when you move something up, down, left, right, it actually doesn't always work the way you think. So if we want to move x plus 4, and we put a plus 4 on the outside, how do you think that would make our graph move? Do you think that would make us move up, down, left, or right? The plus 4 on the outside. Take a guess. Left and right is actually going to be inside the absolute value bars. So since it's a plus 4, it's going to be up 4. Okay, in the same way, if it was a minus 4 on the outside, you would say, well, that's going to move you down 4. Okay, so we still have this normal graph. It was at the origin, and we're literally just picking him up and moving him down 4. Okay, but, we have to move left and right as well. So if we had the plus 4 inside or the minus 4 inside, one way is going to move us left and one way is going to move us right. And it's the opposite of what you think. So you think plus 4 would move you which way on the x-axis? You think it would move you right 4, but instead it moves you left 4. And minus 4 you think would move you left, and it actually moves you right. So for inside the bars, it actually does the opposite of what you think. As long as your number's not inside the bars, it does exactly what you think. Plus 4 on the outside means up 4, minus 4 on the outside means down 4. Okay, but again, even if Jax is not really clicking in with this, I'm about to show him how to do all the things with his calculator. So as long as he types things correctly in his calculator, he can always check himself with the calculator. Are there any questions about this? Okay, we are only doing the graphing problems today. So we're not doing number 1 at the bottom. We're not doing the next 7. We're going to number 1 at the next page. It's page 29. It's at the bottom. It says y equals absolute value x plus 3. Okay. And then we'll graph in the calculator in just a hot minute. But with that plus 3, do you think it's going to move me? Is it moving me left 3, up 3, down 3, right 3?
Left 3.
If you got that and you were ready to scream it out and you're like, duh, then of course it moves you 1, 2, 3 to the left. It's still up 1 over 1. It's still up 1 over 1 the other way too. And if you understood how I did that super fast, honestly, calculator could help you check, but you don't need the calculator. You got this. Maybe you can connect the dots better than I can. Meanwhile, for those of us who are normal like Miss Compton and would like this device to help us, let's talk about how to graph. Okay, so we're supposed to graph, I'm going to write the equation above here so you can see both at once. We're supposed to graph y equals absolute value x plus 3. To graph this, on your calculator, you have to hit the button that says y equals. There needs to be nothing else going on in your list, or else you're going to be graphing other stuff other than what you wanted. We need to tell it to do absolute value x plus 3. I don't see those bars anywhere on my screen, so it takes a little effort to get to absolute value. You can either, if you're smart, you can press third, or the alpha button. Let me zoom out some more. Let me get this to focus. That is not focused. That is opposite of focused. That is still opposite of focus. Get it together. Okay, so you could press third and then type absolute value starts with ABS. So you could press third and then A, B, and the letter S down near the bottom. But if that's a little difficult for you, we could press the button math. It's below that one. It says math. If you press the math button, I don't see ABS anywhere on this first list, but if you scroll over to NUM, I see ABS as the very first button. So let me do that again if you missed it. You press math, you scroll over to NUM, so you'll write one to NUM, and then I see what I want ABS, so you can press enter. Okay, but Miss Compton needs to be on the graph, so we need to press y equals math, number, ABS, enter, and look, now it's got the absolute value bars on the graph thing, so perfect. The letter X has its own button, but it shares it with a bunch of other people. It's like they're roommates. It's got X, T, theta, and N. You need to press it. And then here is where most people make their mistake. That plus 3 is on the outside. Make sure you don't put plus 3 inside those absolute value bars. That's not what your problem says. Your problem says plus 3 out here. It's not your calculator's fault if you don't type things right. It's your fault. You can't get mad at it. Okay, and then you're like, oh, I pressed enter. Oh, Miss Compton, it didn't graph. Well, no. You have to actually press the graph button. Is there anyone stuck here? Okay, so did you went to y equals. Okay, you went to y equals, you pressed math, you scrolled over to NUM, you press ABS, you press the button for X, which has got like X, T, theta, N, it's near the top. And then you want to put the plus 3 not inside the bars. Okay, and then so we press graph. And hopefully your graph looks beautiful like mine. Oh, Miss Compton typed it wrong, didn't I? I put the plus 3. It was supposed to be inside the bars. Why didn't no one tell me that?
I was sitting here and I was trying to.
Why didn't no one tell me that?
I was like, maybe I like missed something. And I'm
So I need to go fix it. So it was supposed to be inside the bars. My goodness, people, and let me do math wrong today. We ain't got time for that. Plus 3 is supposed to be inside the bars. Miss Compton wrote down the problem wrong. Crap. Absolute crap.
I was like, maybe I missed something.
No, I wrote it wrong. Okay, so you go to y equals, you type in whatever your actual problem was, and you probably, unlike Miss Compton, want to check twice that you typed in what your problem was, because I did not. And then when you press graph, look, now it looks like what you and I had graphed on our paper. Okay, whew. If your graph does not look this pretty, because bless your heart, again, you're using a shared calculator. So if your graph is not this pretty, and you would like it to look like this, you need to press the button that says zoom, and then you want to do zoom standard, which is 6. It'll zoom to your graph then. Zoom standard. So again, if your graph is not this pretty, and you want it to do something different, that zoom button will work, And I like zoom standard, but if you play around with it, you can zoom in on things, zoom out on things, zoom where you want. It's nice. Yes, dear.
The reason it's in that quadrant is because of the plus 3 position speed and the length.
Yes, that's exactly it. Okay, so Angel graphed it on her calculator. She's here, and she thinks she's graphed it right on her paper, but she'd really like to make sure. She wants to know for sure that this bottom point on this graph really is -3, 0. She wants to make sure. So she can check that. So you would think, oh, I just scroll. And you can just scroll, but your calculator likes decimals. So then your calculator's like -2.97. But I wrote 3. And that's 2.97. I mean, should I just round and say it's close enough? So if you're feeling like me and that confuses you, if you press trace, it's the button between zoom and graph. If you press trace, you can literally trace your graph. But what's cool about that is you can just ask it. So when you press trace, you could just say, calculator, tell me about -3. And it will tell you, oh, at -3, you're at 0. So again, if you press trace and then the number you're worried about, because we were worried about, is that point really at -3? So, -3, enter. Yeah, it is -3, 0. We are not crazy. It is correct. So basically, I'm teaching you all the calculator shortcuts, because in life, if you knew how to use this, you probably knew how to do most of the things in math class.
Because on the graph, and I hit like second graph, it's like 0, 3, then 1, 4, and then 2, 5. And when we did it, we just went up.
You went to the table and looked at it? Yeah, you could. So she's looking at the table to make her graph. So if you press second and then graph, there's the word table. And then you could literally use those points to plot. Like 0, 3 is a point. Oh, look, you and I plotted 0, 3. That's genius too. But again, and I know Paige did, so I'm going to pick on Paige. If you understood how I got that pink graph to begin with before I started graphing on the calculator, I'm just doing it fast on my calculator to check. Yeah, I'm not crazy. Move on. You already had it. You already got this. Okay, let's go to the next page. Okay. We see absolute value x -4. What do we assume is going to happen to the graph? Down 4. That's what we assume is going to happen. Down 4. So we pick up what was our parent function, and we move him 1, 2, 3, 4 down. It's still over 1 up 1. It's still the same exact thing on the opposite side. It's still a V. And then if you want to graph it with your calculator, you sure could to check yourself. But for real this time, make sure the -4 is on the outside of your bars. And we press graph. And, oh, we're not crazy. It really was supposed to look like that. Awesome. Okay, are there any questions on number 2? What do you think is going to happen on number 3? Look at number 3. What do you think is going to happen on number 3? Say it. Where it's English. We're going to go to the black one. What? There's that negative sign. What do you think that... Say it, Anne-Marie. Yeah, it's going to flip it upside down. Isn't that what you said? That's what I thought you said. Isn't that what you said? I saw you mouth flip. I saw you mouth a lot of things, though. I don't know. I want to give you credit for things that aren't yours. I don't know. I'm putting it in your mouth? Okay, cool. It's going to flip it. So that negative sign on the outside is going to flip down. So we're really, instead of being a happy V, we're still going to go through the origin, and we're still going to go over 1 up 1, but we're going to be a sad V. And if Miss Compton could only graph today. There we go. Whew. Okay. I would like to check myself on this one. I would like to graph this in my calculator and make sure I know what I'm doing. And I suggest you do graph this one because we would like to make sure we know what we're doing. So if you go to y equals, the reason we ought to practice graphing this one is because of that negative sign. Since it was negative x, we're not subtracting anything, so we're not going to use the minus button. We're literally going to use that negative sign. And if you don't use this, and you press the other button that I'm telling you not to press, you press this one, you're not going to get a graph. It's going to tell you there's an error. So when there's a negative on the outside, you need the negative button. Okay, then math and absolute value x. I press graph, I get a graph. If you are pressing the buttons and you don't get a graph right now, I'm telling you what you did. You did not press the negative button, you pressed the minus button. Okay, is there anyone confused about this one? Okay, well then let's go to number 4. And oh my goodness, but let's be brave. We can handle this. We don't need our calculator for this. We got this. The minus 2 plus 3, what's going to happen?
Go up 3.
The 3 makes us go up 3. What does the minus 2 make us do?
Go to the left 2. Right.
It's going to go right 2. So again, it's opposite of what you think inside the bar. So, minus 2, I'm with you. In my gut, I'm like left 2. But no, it's right 2. So seriously, I could just, it used to be at the origin, and now I'm going to go right 2, up 3, and then I do my normal graph. Up 1 over 1. Up 1 over 1. But if you can move that bottom point, which eventually we'll start calling a vertex, we're not that fancy today. If you can just pick up that bottom point and move it the right 2 up 3, you'll have that whole V's graph done. Or, again, you can still graph this bad boy with your calculator. X minus 2 plus 3, and you press graph. And it does look right. But again, if I want to question whether or not that point really is at 2, 3, I could say trace what's going on at x equals 2. Oh, it really is 2, 3. I'm not crazy. Thank you, calculator, for always having my back. Are there any questions about that one? Okay, well then let's flip to the back. We've only got 3 left and we're done. Of course, you realize there's like a whole page that you could go ahead and start practicing on so you wouldn't have homework this weekend, but I digress. Okay, so we see the negative x plus 1 and the minus 2. Let's guess what's going to happen to this graph before we graph it with our calculator. What's the plus 1 going to make us do? What's the minus 2 going to make us do? What's that minus on the outside going to make us do? So if you realize all that the way Paige does, then seriously, just take it from the origin, move it left 1, move it down 2, and then instead of doing a happy V, do a sad V. If you have no idea what on earth Paige was talking about, you need to graph it with your calculator and use the calculator's graph to help you figure out your graph. Paige is not crazy. That does look like what we did. Okay, and then our last 2 are only, I'm going to call more challenging 2, and that's because they put a number outside those bars. So, are there any questions about 5 from anyone from it? So 6 and 7 are the most challenging because of that number on the outside. Again, if you have a number there, that's when it's dilating us. That's when it's either making us fat or it's making us skinny. So I know, again, fractions make you fat. So I assume what's going to happen to my normal guy with the bottom one is it's going to get super fat. And what I assume is going to happen with number 6, when it's a nice pretty number out front, a 3, it's going to make me skinny. So far we've been moving left, right, up, down, and flipping. Now we're going to add in this dimension of PS. You could be made fat or skinny as well. So you can graph it on your calculator and see what happens. To check to make sure Miss Compton's not completely crazy. And you're like, yeah, Miss Compton, it does look skinny. but I don't really know how to put that on my paper. I mean, I just know that it's skinny. So you have two options. Either you could, my one suggestion would be maybe you should graph it along with the parent function. So maybe you should also graph absolute value x by itself. So maybe if you graph both of them, it would help you realize how skinny it got. You could do Angel's suggestion of pressing table. Or Paige is going to rather do this because this is just how she wants to do things. I already know this is how she's going to do it. Instead of going over 1 up 1, that number out front is what we multiply by. So instead of going over 1 up 1, I'm going to go over 1 up 3. So if there was a 4 out front, I would go over 1 up 4. If there was a 5 out front, I would go over 1 up 5. So it's still going through the origin. But instead of over 1 up 1, I'm going over 1 up 3. And you could just keep going over 1 up 3. Over 1 up 3. It's just like when we used to count slope. Except it's the opposite of what you and I would have thought in life. Over 1 up 3. I can't count today. So it ends up making a skinny B. So if either you understood how I just did the over 1 up 3, over 1 up 3, over 1 up 3 because of the 3 out front, or you got your handy little friend and he helps you figure things out, you can press trace, you could graph the parent with it, you could press table, we got lots of options. There's an unlimited amount of options to help you get this graph correct. Similarly with number 7, I'm even going to put him on the same thing. I'm so lazy, I'm not going to erase any of them. I'm going to leave them all there and still do the 1/2. So alpha y equals fraction, I want to do 1/2. Math, I want to do absolute value x. I press graph. Now if we had a fancy colorful calculator, they'd be in 3 different colors. We're not that cool. So we had the normal one, we had the super skinny one, and now we've got the super fat one. So we've got to get this super fat one on our paper somehow. So you could, like Angel, use table. You could use trace to help you figure it out. Or, if you're thinking your mind through this, it's still going through the origin, but instead of over 1 up 1, we're going over 1 up 1/2. Instead of, so I could still just go over 1 up 1/2. Because of that 1/2 on the outside, instead of over 1 up 1, I'm going over 1 just up 1/2. So I keep on just going up halves. And you'll end up with the exact same B. So really, Paige is not even going to use the graphing calculator because she's got it in her head. She's going to use it to check herself. And I think that's brilliant. If you need the graphing calculator, no big deal. I'm never going to know how much you rely on it as long as you make sure you put all the stuff you need on your paper. Okay. Are there any questions about this? If you're being wise, your homework that's going to be due Monday is 32 through 34. It's in the same package, 32 through 34. And if you recall, you kind of forgot this past Monday that you had homework you were supposed to turn in. So would it be a good idea to get a head start on this one? Probably. You don't want this